Hi, my name is Tirumurugan. I'm from Group 6, Section 7, BEV 20901, Electrical Engineering Laboratory 2. So today I'm going to do a stimulation for Experiment 1, Part A, Activity 3. So I need to construct a stimulation based on this circuit. This is a DC circuit connection. So let's get started. So I'm using Proteus as my stimulation for the stimulation. So we need resistors. So we need resistors, one of the component for the circuit. We need two resistors. And then we need a meters. This is a DC circuit, so we need to use a DC ammeter and a DC voltmeter. DC ammeter and a DC voltmeter. Okay. Then we need a battery. Battery as the power supply for this circuit. So this is the component for this circuit. So let's rearrange this one with okay, like this, and then wait, okay, like this, and then this. So okay, so now we connect the components, all the components. So we connect resistors, and then here, then from the emitter to power source, then from wait, just okay, we need to connect from here, from this resistor to power supply. Then we connect the voltmeter parallel to the power supply, which is battery. So just move here. Okay, just delete this one, make it proper. Okay, so we're using two resistors. One of that is R load, which is this one. So we use it as R load, RL, and then this one is a internal resistance for emitter. So we connect series to the emitter. So this one is a internal resistance for this emitter, or which is known as RA. And then this is our power supply. We set as U in, and then we need to set the value for this all the components. So we set the value for RL based on the table given in the experiment. So we need to set as 100 ohms for RL. For RA we need to set as 15.5. So this is a fixed for internal resistance of ammeter, 15.5 ohms. And then for power source we set as 10V. So this one also fixed in this experiment. So then we need to start the stimulation. Before that, we need to change the range for ammeter from ampere to milliampere, because in the table they ask the result in a milliampere. So we set the ammeter in a milliampere, and then we get started. Then what we have here is for the ammeter we have a 86.5, and then for the voltmeter we have a 9.99 volts, which is 10 volts. This is the same, so the reading is the same. Then we stop the stimulation and change the RL to 100, from 100 to 150, and then we run the stimulation again, and then we have a 60.4 milliampere, and then voltage still the same, 9.99, which is 10, equal to 10. And then we stop, then we change to 300, the last one for RL. So we change the 300, and then we have reading of 31.7 milliampere from ammeter, and then 10 volts from voltmeter. So after we did the stimulation, we need to find I1 from circuit, I1 reading, and a percentage of relative error. So just now we did the stimulation, we get the measured value, I1 measured. So for RL 100 we have 86.5 milliampere, for 150 RL we have a 60.4 milliampere, and then for RL 300 we have a 31.7 milliamperes. So after that we need to find I1 from circuit, I1 reading, and a percentage of relative error. So we need to find it by using the formulas are given, and then the values for I reading and I measure is the same, exactly the same if we use the formulas. For relative error we need to find it in the percentage form. For the I reading from circuit and I1 reading, we need to find it in a milliampere. The final answer must be in a milliampere form, because the formulas given are in amperes. So we need to change it to milliamperes. That's it from me. Thank you.